of you. Okay, well, welcome. We're planned today is to continue on talking about relations, equivalence relations today. And so I also just want to point out our next exam is scheduled for a week from Wednesday. And that's set to cover induction and relations and stuff that we're talking about right now. I realize that there is an election, obviously, the day before that exam. So the election's on Tuesday. We're set to have the exam on Wednesday. I'm just kind of curious how you guys feel about that. If anybody feels really strongly about like that's a bad time to have an exam, I figured I want to hear that from you. And maybe in the interest of keeping this somewhat anonymous and I guess only open to those that are here, here's a question that I'll pose to you. This is anonymous, but my suggestion would be to either move it to the Monday after that, or I don't care. So it's either leave it, move it, or I'm okay with anything.
Will the format be the same as all?
Yeah, it's going to be, if you have it on Monday, it's going to be way harder. What do you want to do now? No, it'll be the same exam. There's going to be no impact on the exam, just the timing.
I mean, exam 2 compared to exam 1, something like during the class, we have multiple choice and then some.
Yeah, it's going to be the same format as the first exam. Yeah, similar to that. Okay, so I think everybody that is here has voted, or at least people that were here when it opened up. So here's the results. Half said whatever is fine. 4 said they prefer to move it. 1 said prefer to keep it on Wednesday. Now you can. You don't trust me. This is a fair election. This one is a fair poll right here. Yeah, so I guess that's not overwhelming evidence in either direction, but in interest of the 4 people that outweighed the others, we'll move it to Monday on November 9th. So I'll update that on the syllabus. So it's not going to affect the exam or the content that's on the exam, just the day that we have it. That's fine. I think Tuesday night might be a late night. You might be focusing on some other things. So we'll have that on Monday. So I will post an announcement about that. If you have any questions or issues about that, just feel free to reach out to me.
Will we move the content that we're learning that Monday to the Wednesday? Will we just flip those 2 days?
Yeah, so the plan was whatever we were to talk about this week would have been the last stuff on the exam, and then Monday we would review, and then you would have had the exam on Wednesday. So we'll just continue on. The stuff that we cover next week won't be on your exam, and we'll still have a day to review. So kind of next week, we'll just say like the stuff that we do on Monday, it might be finish up some things that we don't finish up this week, and then we might start some new stuff on Monday that won't be on the exam. Next week, we'll review on Wednesday. So post-election day, we'll just have a review, and then that Monday we'll have the exam.
Thank you.
Yep. Yeah, so it's just going to be flipping 2 classes around. It won't affect things otherwise. Okay, great. So anything else before we get started for today?
I had a question.
Yeah, sure.
There was a problem from the Cartesian product worksheet that you left us to think on. It was number 7. If A times B times C equals A times parentheses B times C.
Mm-hmm.
And I was wondering if you could go over that.
Yeah, sure.
Briefly.
So that would be this one here, right?
Yes.
Yeah. Yeah, so this, in case you're curious, this was on the worksheet on Cartesian products. And yeah, so the last one was something that we kind of left hanging. And so, yeah, so this statement is actually false statement, because if you think about what the things would look like in each of these sets, if we take A cross B cross C, then that would mean these are going to be things where the first coordinate is actually an ordered pair of coordinates. And then we have another element as this other coordinate, whereas if we were to consider something in A cross B cross C, now we're saying this would consist of elements that would look like, for example, 1, 2, 3. So it's just this one over here has an ordered pair as its first coordinate and then a number as its second coordinate, whereas this one over here has a number as its first coordinate and then an ordered pair as the second coordinate.
Okay, I got it.
So the takeaway here is that it does not follow like the associative property. Like when we multiply, I can do A times B, then C, or I can do B times C and then multiply by A. And we can change the ordering that you do that around. That's not the case with these Cartesian products. I don't know. Does that help with that one? Okay. Anything else? Okay, so then we'll talk about, this is worksheet 17. So here we're talking about properties of relations. So we're in chapter 11 of the text. This is the second section of that. So the first section, last time we talked about what are relations on a set or from a set A to B. And so now I want to talk about some properties that relations may or may not have. And so among others, the three most common ones that we might be interested in are to see whether the relation is reflexive, symmetric, or transitive. And so that's what your reading assignment was on, just making sure you familiarize yourself with those definitions. So we say a relation is reflexive if A is related to itself, and that's true for all A in the set. We say it's symmetric if A related to B implies that B has to be related to A. And we say it's transitive if A related to B and B related to C implies that A must be related to C. So I want to take a look at some common relations and just based on these relations, identify which of these properties may or may not hold. And so we'll kind of break these up shortly and have you think about some of these in breakout rooms, but we can do some of these together. So let me just add one over here, which will be like, we'll call this like the Facebook relation on people. And so we'll say X is related to Y along this relation if X happens to be a Facebook friend of Y. Then we say that these are related to each other. So let's think about these properties. So reflexive property. Does the Facebook relation satisfy a reflexive property? Chat them in, or you could open up a poll. Just kind of curious what your gut would be on that one. So I'll just launch it. So actually, I'll have you think about all three. Do you think this is reflexive, symmetric, transitive? And there's no math to do here. So these should be kind of just a informal, quick check about what you might think. So here's kind of the idea here. We're thinking about whether or not this is reflexive, then we're trying to see, is it true that Bob is related to Bob for all Bobs? Okay, I don't think we have any Bobs in here. And that's the idea of what we're trying to calculate. So here are the results in case you're curious where everybody was falling on this. So as far as Facebook goes, can you friend yourself? I don't even know. I don't think so. I don't know. I don't think that is possible, but maybe with an update, you should be able to friend yourself, but it's not really, that's not really an issue when it comes to this, but I think it's a no here that you can. If we want to see whether this is symmetric, then what we're thinking about, if Bob is related to Sally, then Sally should also be related to Bob. And is that true on Facebook? Yeah, and so everybody said yes. I do believe that's how Facebook works, is that you can't friend someone unless they accept your invitation, and then you're friends with each other. Okay, and then the last one would be transitive. And so this would be saying, okay, well, let's say that Bob and Sally are related, and Sally is related to Sam. And then we'd like to know, does this therefore imply that Bob is related to Sam? And let's see, survey said, 8 said no and 2 said yes. And I will just say that this one is not true. This is a false property. This is a no here because, right, you certainly are friends with people who have friends that you're not friends with. And that's what's going on there. Okay, so let's try maybe one more of these. Any questions about that? So let's try one that is a little bit more mathy. So the next one I think is like an equal relation. Okay, meaning we're going to say x is related to y if x is equal to y. That's what we mean by the equality relation. So according to this relation, does this satisfy the reflexive property? Okay, that's, yeah, x is equal to itself. And here I think we were defining this relation on the real numbers. Okay, since x is equal to x for all real numbers. So that is true. And so as far as symmetry goes, is that going to be the case if we're dealing with the equal to relation? Yep, that's fine. Since this would imply that x is equal to y, so if x is equal to y, then certainly y is equal to x. That's what's going on there. And then the third property would be if x is related to y and then y is related to z, does this imply that x has to be related to z? What do you guys think about that?
Yes.
Yep, that's yes. So if this is the case, then that means x equals y. And if this is the case, that means y is equal to z. And so if x equals y and y is equal to z, then certainly that would imply that x is equal to z. That satisfies the transitive property.
I have a question for you.
Yeah.
Would we expect some of these to have different results when dealing just with integers as opposed to all real numbers?
Some of these might have different properties depending on the set on which you define it. Yes.
Okay.
Okay, so that's the gist. In each of these cases, we would want to check these three properties for the relation. So I'm going to kind of split us up into groups and split us up to think about different problems in different groups. And then when we get back together, have the groups try and explain your thinking to the others. So let's see, we've got 12 people. Let me open up these breakout rooms. Okay, so let me just check in with the groups about your answers here then. So, so for Alex, Molly, and Wilfred, for the not equal to one, what did you guys get for these properties?
So I wrote it on the whiteboard, and I'm not sure how to look at what I wrote, so I can't remember now.
I got
You
it
probably
then.
had to export it.
So we said that it is not reflexive, that it is symmetric and not transitive.
Okay, and one thing that kind of came up in chatting with some groups is that these are like proofs in themselves. They're either conditional statements. A lot of them are conditional statements. So like symmetric and transitive, these are conditional statements. Reflexive is a for all statement. So when you're trying to consider these things, you would want to show, in order to prove that this is true, you would want to show that for everything in our set, it is related to itself. And if you want to show that the property does not hold, then you just need to give one counter example. So for the not equal to property or relation, said it's not reflexive. And so what would the proof of that claim be?
X cannot not equal itself.
Yeah, and so let's give a concrete counterexample. So we're defining this on the real numbers. So what is a real number which is not equal to itself? Or that would disprove that?
X equals 1.
So is 1 related to 1 in this relation? Well, if so, that would mean that 1 is not equal to 1, and that is not true, right? So then the proof here, let me clean that up, would be consider X equals 1, which is a real number. And for this, we see that 1 is not related to 1, since 1 is equal to itself. So that would disprove the reflexive property with a counter example. And you said that it was symmetric. And so if we want to prove that, then we need to prove a conditional statement, right? Which says, so let's suppose that X and Y are real numbers. Okay, with X not equal to Y. Okay, then according to this not equal to relation, X would be related to Y. And that proves that this is symmetric, right? Since we did this arbitrary for all X and Y in real numbers with X not equal to Y. And then for the transitive property, You said that this was a no, and what's a counterexample for this?
If x is 1, y is 2, and z is 1.
So here we can take element x, and it is true that 1 is not equal to 2. And over here we can say that 2 is not equal to 1. But now we're not getting back the relation that 1 is related to 1. Okay. Any questions? So those are all correct. This was the correct breakdown for not equal to. Okay, then Brandon, you guys were working on the less than or equal to relation, and what'd you say about that one?
Said that reflexive was yes, symmetric was no, and transitive was yes.
Let's see, and that looks good. Yep. And so I don't know, did other groups get a chance to, that weren't assigned this, get a chance to think about it? Let me know if you want to discuss it. Just, you can hit a chat and say, hey, can you talk about this? If I don't hear you, then I'll assume that it's okay. Okay. John, the same parity relation, what'd you say about that one?
We said that it was all three: reflexive, symmetric, or symmetric and transitive.
Okay, and that checks out. Thank you. And then for the less than, what did you get for that one?
We got that it was only transitive.
That's right. So to kind of compare this to the one which was less than or equal to, we lost the reflexive part of that because, right, we're no longer including equality in that. Okay, and then Brandon, for the, I'm not calling on Brandon, anybody that was in Brandon's group, for the divides, what did you guys say about this one?
We had reflective was yes, symmetric no, and transitive yes.
Okay, that looks good. And then for the last one, that was Alex's group. Alex, Molly, Wilfred, what did you guys say about the y equals x cubed relation?
So we said yes for all of them.
Okay,
Did we
Is that
say yes for
correct?
the first one?
sorry?
For reflexive?
You said it was not reflexive or was reflexive?
Sorry, never mind. I just can't remember.
I believe we said no for all of them.
Okay, so we're getting some differing opinions here. So this is one maybe that's worth taking a look at. Any of the others, I didn't get any requests, I don't think, for going back over one of them, but let me know. Okay, so let's take a look at this y equals x cubed relation. And so this is going to be some subset of, we're defining this on the real numbers, of R cross R, because these are going to consist of points x comma y. And so we're going to say that x, what this means is x is related to y if y is equal to x cubed. That's what we mean by this relation. So the, if you are familiar with this graph, right, basically we're saying our relation would be the set of all points on that curve. And so if we want to check whether it's reflexive, then we want to see, is this related to itself for all real numbers? So for example, like, is 0 related to 0 according to this relationship? Well, then the question is, like, is 0, 0 on the graph of y equals x cubed? And it is, okay? So that's over here. So 0 is related to itself by this. Okay, 1 is related to itself by this map, but we need this to be true for all elements. So in this case, 2 is not related to itself, since 2 is not equal to 2 cubed. It's one way to think about it. Okay, and another way to think about it is, well, the ordered pair 2, 2 is not on the graph of y equals x cubed. So this relation would not satisfy the reflexive property. It works for some values, but it needs to work for all of the values.
So I found our whiteboard, and we actually did get false for all 3 of them.
Okay.
But we did the next question too, and that's what the trues came from. So
Oh, that's my bad then.
Okay, yes. So you're thinking about that is right. So y equals x cubed actually does not satisfy any of these properties. So the reflexive property, we can see, breaks down here for certain values. It works for some of them, doesn't work for other ones. And again, we need it to work for all of the values in our set. So it's not reflexive. It's not symmetric. And what's an example of why it wouldn't be symmetric?
basically anything besides -1, 0, or 1 wouldn't.
Yeah, so we can say like 2 is related to 8, but 8 is not related to 2, right? Since 2 cubed is equal to 8, that checks out, but 8 cubed is not equal to 2, so that one doesn't check out. Yeah, and it's not transitive for probably many examples. Okay, so we can say 2 is related to 8, 8 is related to 8 cubed, 8 cubed is not related to 2. Okay, so for this one, this would be no and a no and a no. This is a yes and a yes and a yes. It's basically it's no different than that relation over there, right? It's pretty much the same one as the top one.
I think we had a question about that kind of.
Yeah.
And that helped us out a lot, but I mean, is there really any difference between thinking about the equality as a function and just saying the relation is they are equal?
It's that not all relations need to be functions. So let me say that a function is a type of relation where each input gets only one output, but we can define relations where the input is sent to is matched up with several values in the other set. So sometimes you can define relations with an equation, and sometimes we can't. And so we're just used to, when we study math, we're always studying things that satisfy function relationships. When we take pre-calculus, calculus, we're only dealing with functions. But there are all types of other relations that are worth studying that don't necessarily have those properties. Okay, so yeah, some of these get a little bit trickier. Maybe let's, not to belabor this, but let's maybe think about two more, and then the others I can just kind of put up there. I wouldn't worry about this stuff too much. These are a little bit weird with these sister relationships, but you're welcome to consider them. But let's think about this power set and this nearness relation is what's going on in the other one that I circled. So the question is this relation on, which is the subset relation on the power set of X, what sort of properties does this satisfy? And so now our elements are going to be sets inside of this power set.
Wouldn't it be the same as the one we just did the less than or equal to one?
Well, it's going to be different because we're not thinking about how many elements are in it, but it might be similar sort of argument, but we're dealing with different things here, right? Our relation is not, is this thing less than or equal to that, but is this thing a subset of that? So we've got different elements. Our elements are not numbers, but our elements are sets. And then we're dealing with this subset as the thing that's defining our relation. I think it might shake out pretty similarly, but let's take a look.
Are we asking, I mean, do we have to compare this as sets, or can we just say anything and is it a something that becomes a set in the power set? I'm not sure.
Well, I mean, first of all, if the thing that's defining our relation is a subset, then clearly we should be thinking about these things as sets. And anytime we're working with power sets, yes, we always should be thinking the elements are sets. So here, what we're thinking about is A is related to B if A is a subset of B. So that's the relation that we're thinking about here. So for the reflexive property, we take a arbitrary element in our set, which would be A, is a set inside the power set of X. And the question here is A related to itself? What do you think? It is, because we have that little equality thing on the bottom, right? So that's like an inclusive thing there. If we get rid of the bar underneath here, then that wouldn't be true. It's kind of like the less than or equal to versus the less than. So this is reflexive. This was kind of, this is A related to A was just kind of, here's what we need to check sort of thing. But for any element in the power set, it's going to be a subset of itself. So that checks out. What do you think about symmetric?
I think it's false.
Right, and going to be false. So here, yeah, I mean, you can say this. Oops. Okay, then that's only going to be true if the two sets are equal to each other. So otherwise, if the two sets are not equal, then they're not going to satisfy the symmetric property. So that rules out the symmetric property. It happens for some cases, but not for all. And what do you think about the transitive property?
True.
Yeah, that's true. So here what we're saying is if A is related to B and B is related to C, does it follow that A is related to C? And so if we've got A is related to B, then that means A is inside of B. And if B is related to C, then B is a subset of C. Oops. Okay, so then if X is in A, it follows X is in B, since A is a subset of B. And if X is in B, since B is a subset of C, we know that X would have to be in C. So A is a subset of C, and that transitive property holds. Any questions? So for this one, we said yes and no and yes. Okay, I think we're getting the gist of this. You guys want to do the nearness one, or you getting the gist of it?
I'd like to see the nearness one.
Okay, we can do that. Sure. So now we're going to define the n epsilon relation on the set of real numbers. Is that what it was? Yes. For some fixed positive epsilon value. This is not showing up here. Let me reshare. Okay, here we are.
Is that capital N the nearness relationship? I don't think I've ever seen that before.
Yes.
Well, I mean, we saw it last week briefly.
We defined it when we looked at the relations worksheet. We did it along with the total and empty relation. But I can explain it again. I just don't, like, I'm writing something right now and you guys don't see it as far as I can tell, right?
No.
Yeah, that's correct. Can't see anything you're doing.
Let me, one more time, and then we'll have to use their whiteboard if this doesn't work. Okay, I might give up with that. And let's just use this whiteboard over here. Yeah, so this nearness relation n epsilon is a way that we can define a relation. In this case, is going to be defined on R. And so here, epsilon, this is horrible. I really want my iPad.
Can you try a whiteboard on the iPad?
I need to share, so I'm using my computer, which has Zoom, here we go, and my iPad I'm writing on, so I'm not using Zoom on my iPad as part of the problem. Okay, I think we've got it. So yes, so we're gonna define this nearness relationship on the real numbers where we say X is gonna be related to Y by this relation if X minus Y is less than epsilon. So what this means is over here, we consider this like the real numbers. We pick some value X and we fix epsilon is a fixed positive number. We think of it as a small number. So we're going to go epsilon above and epsilon below, and then any values that fall within epsilon of X are going to be related to X by this nearness relation. And so we did one example last time with this, but for example, if we set, say, epsilon equals 0.1, then we would say, for example, 1.2 is related to 1.25 since it is within 0.1 of the other, right? So that would be related by this nearness relation. So basically it's saying, you know, what are all of the values that are within epsilon of X? So what do you think about the reflexive property?
True.
Yeah, so X is going to be within 0 of itself, right? So for any epsilon value, that's going to work. Right, since the absolute value of X minus itself is 0, and that's going to be less than any epsilon that you pick. So no matter what we pick for epsilon, the reflexive property is going to be satisfied. What do you think about the symmetric property? If X is related to Y, then do you think Y is related to X?
Yeah, true.
Yeah, that is true. Since we can start with saying if X is related to Y, then we know that X minus Y is less than epsilon. Okay, and then we can note that X minus Y is equal to the absolute value of Y minus X. And since we're saying, since we can flip the order of that difference and still satisfy the same property, then y is going to be related to x by this property as well. Any questions about that one? And then lastly, this symmetric property, what we want to check is if x is related to y and y is related to z, then does this imply that x is related to z? So what are your thoughts on that one?
Be false.
Yeah, that one's going to be false. So, you know, if we think about this number line example, right, I can pick y over here and then go the same distance on each side of y. So I'll call this y, and then we go epsilon above and we go epsilon below, and then we can pick some value inside of here, z, right, which would be related to y by this nearness relationship, but it is not related to x because it's a little bit further away. So this would not satisfy that transitive property. And you can write out a concrete example here by picking value for epsilon, x, and y. So for example, to disprove this, we could say, you know, let's let epsilon be something easy. Let's let epsilon be 1. Then we can see that 1 is related to like 1.7 because 1.7 is less than 1 unit away from 1. And 1.7 is related to 2.5 because that is less than 1 unit away, but 1 is not related to 2.5. So that violates that transitive property. So coming back way up over here, this was a yes and a yes and a no. Okay, so I will kind of, the rest of these problems are really just some exercises for you to continue working with these ideas of reflexive, symmetric, and transitive. But I want to kind of leave this with where we're heading next time. So we've been talking about 3 properties of relations that are reflexive, symmetric, and transitive. And so we say that if our relation R all 3 of these properties then R is called an equivalence relation. And this is what we'll focus on next time, is how can we prove that a relation is an equivalence relation? Well, that's going to require us to prove that these 3 properties all hold. And we'll see why, in particular, these are nice properties that we would want to hold for a relation. So we're not requiring a one-to-oneness or uniqueness, or we don't need it to be a function in order for it to satisfy these properties. Okay, so I think I'll stop here for the day, a couple minutes early. Since I don't want to jump into this idea, we'll talk about this next time. So if you have any questions or you want to go over anything that we didn't get to on the sheet, you're welcome to stick around. Otherwise, I've got office hours. Tomorrow, I will, you've got homework that is due tonight. I will get up your next homework assignment, if not later tonight, sometime tomorrow morning. So that will be due next week. And then just recall that next week we aren't having the exam. The exam is going to be 2 weeks from today. Okay, have a nice afternoon, everybody. And if I don't see you before then, see you on Wednesday.